while also expanding its boundaries for the whole community of researchers to disseminate the findings to the entire world. This moment, as the past symposia and conferences, contributes immensely to explore an avenue of value addition to the Sri Lankan resources. Even in the critical context where whole world faces COVID-19 pandemic at the moment, International Research Conference of OLS University, IRCUWU2021, still step ahead on exploring new horizons to combat difficulties by opening its International Research Conference under the theme Exploring Potentials in Challenging Periods, enabling the opportunities for the greater minds to commit for the novel changes in the world through their knowledge and expertise, sharing overwhelming the threats. Honorable guests and all the respected invitees, it's a great honor to welcome you all to the 5th International Research Conference of OLS University 2021. To add blessings to this event, it's time to light up the oil lamp. So I would like to cordially invite Professor Janla Ratnasekara, Vice Chancellor of OLS University, Professor H.M.J.C. Pitawala, Dean, Faculty of Applied Sciences, Professor H.M.S.K. Hera, Dean, Faculty of Animal Science and Export Agriculture, Mr. G.H. Abevira, Dean, Faculty of Management Sciences, Professor K.B. Vijayasekara, Dean, Faculty of Technological Studies, Mr. Hibatul Karim, Registrar, Ms. Taranga Pereira, Bursa, Acting Librarian, Palika Vidana, Mrs. Palika Vidana, also the coordinator of this event, Dr. Rasanga Samaravira, and the secretary of this event, Dr. Titus Gure. Please come and light the oil lamp, and we also remind you, please keep the maintain the proper distance when you are lighting the oil lamp. Thank you so much, sir. Now I would like to invite you all to raise for the university anthem and the national anthem.
Sundara Siri Varini IRCUWU2021 University remarked the honor in organizing the 5th International Research Conference. I respectfully invite Dr. Rosanga Samaravira, Coordinator, IRCUWU2021, to formally welcome the gathering.
Good morning, ladies and gentlemen. Honorable Chief Guest, Professor Sampath Amartunga, Chairman, University Grant Commission, Sri Lanka, Vice Chancellor, IRCUWU2021 University of Sri Lanka, Professor Jayanthala Ratnasekara, keynote speakers, Professor Ramesh G. Mani, Georgia State University, Atlanta, USA, and Professor Yu Song Wei, University of Chinese Academy of Sciences, Beijing, China. Dear Deans of the Faculties, Registrar, BESA, Head of the Departments, Academic Staff Members, Administrative Staff Members, Non-Academic Staff Members, Resource Person, dear authors, presenters, and all the participants. It is my pleasure and honor to welcome you all to the International Research Conference of IRCUWU2021 University of Sri Lanka 2021. Research is the foundation of knowledge. The knowledge that creates through research should be shared with the entire world to make it useful for others. We, as IRCUWU2021 University of Sri Lanka, has identified international research conferences as such a platform for disseminating knowledge to the world. Throughout the last decade, IRCUWU2021 University has conducted 6 symposia and 4 international research conferences. In keeping with tradition, we plan to have conventional international research conference in 2021. However, due to the current global pandemic situation, we had to progress with the virtual conference. We set our theme as exploring potentials in challenging periods, aiming to uncover new avenues for combating current local and global challenges. Our objective of selecting such a theme is to be a beacon awakening our capacities in such a difficult period. Same as the 4th International Research Conference in 2020, with the guidance of Vice Chancellor and the direction of the Research Committee Chair, we accepted our first challenge of having an international research conference even in the pandemic situation. Even though the world is going through a difficult time, it seems like the researchers have overcome it very well, because we received more than 550 abstracts from the researchers under 10 thematic areas. Among those submissions, after a competitive review process, we choose about 280 abstracts to present in today's conference. Today is the culmination of all our efforts. The researchers will present 280 research findings as oral presentation. The IRCUWU2021 has a unique feature in that of all the selected papers will be presented as oral presentations. During the presentation, we will select the best research work using a specific evaluation criteria. I appreciate all the parties for being with us and congratulate all the presenters and authors. Hope you will be enjoying the conference. Thank you.
Thank you so much, sir. Now, I take this opportunity to invite Professor H.M.J.C. Pitawala, Chairman, Research and Academic Publication Unit, Dean, Faculty of Applied Sciences. A great pillar behind this event to address the gathering with your valuable thoughts.
Very good morning to all. Honorable Chief Guest, Senior Professor Sampath Amartunga, Chairman, University Grants Commission, Professor Jayanthala Ratnasekara, Vice Chancellor of IRCUWU2021 University, keynote speakers of today's conference, Deans of the Faculties, Registrar, BESA, Acting Librarian, Heads of the Departments, Organizing Committee members, all academic staff members, all administrative staff members, all non-academic staff members, and all the presenters. It is my great pleasure to address and share few words with you all as the chairman of the research committee and also as the dean of the faculty of applied sciences, who organized this conference this time. When I prepare my speech, two questions came to my mind. First one, why we do research? The second one, why we organize research conferences? If I answer to my first question, why we do research? We do research to get our PhDs, masters, bachelor's degrees, and also to find out solutions to complex problems, and also to make new discoveries and develop new products, finally, to improve our lives. If I answer to my second question, why we arrange research conferences, of course, it will provide an invaluable opportunity for learning, networking, and exploring new ideas. Also, organizing events will develop our soft skills like communication and teamwork. Everyone in the world understands the importance of doing research. For example, European Research Council spent around 13 billion euros from 2014 to 2020. The allocated budget to Council of Scientific and Industrial Research of India for 2001 to 2002 is $1 billion. Annual budget of National Science Foundation of United States is 8.3 billion. In Sri Lanka, the estimated annual allocation of National Research Council is 349 million Sri Lankan rupees. So, of course, this is also a not bad number because we are a developing country. So, but what we have to do good research and improve ourselves. Because I will provide some data in SAARC countries. First, I would like to thank Dr. Pradeepan. He gave me this data. In India, they have published 21 lakhs publications. Pakistan, 2 lakhs, around 2 lakhs publications. In Bangladesh, they have around 67,000 publications. Sri Lanka, we have 26,000 publications so far, and Nepal, we have around 20,000 publications. So we have to go further. However, we can happy about ourselves as a young university of IRCUWU2021 University. If I provide a brief summary about research output of IRCUWU2021 University, according to the research awards of our university, we have published full papers in 2016, 12 publications. In 2017, it was 25 full papers. In 2018, it was increased up to 57, double the number. And 2019, this time, we have 84 full papers. So, of course, therefore, today's conference also will help to increase this number. Of course, before I finish my speech, I must thank the organizing committee, Dr. Rasanga Samaravira and Dr. Titus Kure and his team. Finally, I congratulate all the presenters and authors, and please enjoy the conference. Thank you very much.
Thank you, sir. I request and welcome Honorable Vice Chancellor of IRCUWU2021 University, Professor Jayanthala Ratnasekara, the cornerstone of success behind UW Fabric and this event, to address the gathering with your words of wisdom.
Very good morning to all. It gives me great pleasure to be present with you all on this special occasion, inauguration of the International Research Conference of IRCUWU University, IRCUWU2021. It is indeed a special occasion as we organize this conference as an online conference for the second consecutive year. As the Vice Chancellor of IRCUWU University, let me also warmly welcome our chief guest, Chairman University Grants Commission, Senior Professor Sampath Amaratunga, who is joining us online, and the keynote speakers, Professor Ramesh Ghani of Georgia State University, USA, Professor Wan Son Wei of University of Chinese Academy of Sciences, other invitees, and all the presenters. Of course, as the Chairman Research Committee, Professor Pitavella mentioned, we all know that the international conferences, international research conferences are great opportunities, not only for researchers and scientists, but also for students, policymakers, and other stakeholders as well. International research conferences gives us an opportunity to connect with researchers and scholars with different perspectives and views, to learn from them and to have relationships. The international research conferences, where the international researchers and scholars participate, gives us opportunity to meet with people, connect with people. If it is online, of course, connect with people from different countries and to initiate new collaborations for further research work. Of course, COVID-19 global pandemic has changed the entire landscape of human life, but opening the gaps in human knowledge, processes, and technologies. The current situation, the global pandemic situation, reiterates the need for generation of new knowledge to answer the problems which has occurred recently and for a long time, as well as its dissemination and application. It is in this context, the theme of today's conference, exploring potentials in challenging periods, this becomes important. Exploring challenges, exploring potentials in challenging periods such as global pandemic. I firmly believe that the IRCUWU 2021 will provide a fruitful platform to share the research findings and exchange views for further collaboration and further development of research among scholars from different countries, despite the restrictions imposed due to the COVID-19 pandemic. I congratulate all the presenters, those who will share their findings at IRCUWU 2021, and in turn contributing to the research creating of new knowledge. Finally, I would like to thank the organizing committee of the IRCUWU 2021, as well as all the members of the UW family for their untiring efforts to make this IRCUWU 2021 a success, despite the travel restrictions and other all health guidelines during this pandemic. Thank you very much. Wish you all a very happy and productive conference. Thank you.
Thank you so much, sir. To introduce our guest of honor to the gathering, again, I would like to invite Professor H.M. J.C. Peter. Sir, it's over to you.
Thank you very much, Duranga. So it is my great pleasure to introduce our chief guest, Professor Sampath Amartunga. Professor Sampath Amartunga is incumbent chairman of University Grants Commission of Sri Lanka. Prior to this post, he has served as the Vice Chancellor of the University of Sri Lanka from 2014 to 2020 and as the Dean of the Faculty, Management Studies and Commerce of the University of Sri Lanka from 2008 to 2014. He obtained his BA Honours degree in Economics and his MA in Economics from University of Colombo. Later, he obtained MSc in Economics of Rural Development from the Saga University and a PhD from Ogasawara National University, Japan. Professor Amartunga counts over 25 years of service as an academic at the University of Sri Lanka. He has published more than 50 articles in international and national refereed journals and proceedings. Professor Amartunga was also a recipient of the prestigious Research Excellence Award in 2002, awarded by the QC Society of Rural Economics, Japan, which is an addition to several other local and international awards. He is considered as an expert in the field of economics with special reference to rural development. From 2012 to 2014, Professor Amartunga rendered his service as member of the University Grants Commission of Sri Lanka and several other commissions and takes pride in being the youngest professor ever appointed to the University Grants Commission. He was the chairman of the Federation of University Teachers Association, we call FUTA, of Sri Lanka from 2009 to 2012. Professor Amartunga commands respect not only from the academia, but also from the corporate world. He has also served on the director boards of certain prominent companies in Sri Lanka in the capacity of an independent director. Professor Amartunga is a renowned personality whose service extends far beyond the university community to the society. So now I would like to invite Professor Sampath Amartunga to address the gathering.
Thank you very much and very good morning, Vice Chancellor, Professor Jayanta Ratnasekara, all Deans of Faculties, Chairman of the conference and the conference team, academia, registrar and his team, keynote speakers from all over, participants, ladies and gentlemen. Thank you very much giving me the opportunity to speak few words today in a vitally important conference like this, that we all know that we are in a pandemic, global pandemic situation, and this was hit all of us for the last for the last 15 months. So I would like to share the screen just to show you some statistics as well. Before me, very valuable information was given how countries spend on research and development, especially in the region, how India allocate money for research as well. And also, he has mentioned that we are not bad. And according to his information, he has only concerned the National Science Foundation. But there are more other sources that research funds being allocated to the system as well. So let me share the screen. What is it? Okay. Make it. If you all can share the screen, I have given a copy just now to the organizing committee. What is it? Is it possible to share the screen from there, Professor Jayanta? Okay, thank you very much. Yes. This statistics shows how the system function today. So according to these three waves taken place in our country, this shows how higher education functions. So all credit must go to all 16 national universities and 18 institutes, including Learn, which is our premier service provider. This bluish part, or the first step of our slide, shows the first pandemic situation. So 2020 week number 13 is up to 20th of March 2020. You can see before the 13th week, we have never ever practiced any class, any examination, any learning online. So we have started from the beginning. And within the first wave, we have done classes and participation is very high. And you can see the second wave, how the development has taken place. Now we are in 2020, week number 25. Just we have concluded this week. You can see every week in our system, we conduct 0.8 million classes. This you have to compare with 0, that is 2020 before 20th March. And today, the participation is very high. this you get the total participation that counts nearly 1.7 million. So you can see with the pandemic how the higher education sector cope up and continue education. So we have this strength within the system, and that is the main reason why that we have finished the final years last year and inaugurated for the first years. Could you please go to the second slide, please? This is very important for IRCUWU2021. This is data of all main publishers. You can see this. I have taken 7 universities: Japura, Colombo, Kelaniya, Moratuwa, Peradeniya, Jaffna and Ruhuna. I'm really happy the speaker who started today's proceedings mentioned about these numbers. So it's very good. That shows IRCUWU2021 is managing the situation, and IRCUWU2021 knows about how to achieve ranking, which is the most important. You can see Colombo and Peradeniya well set, and they are above 400 high quality, high standard, full papers. They all publish these papers in above databases, the world highest ranked databases. And also you can see Colombo have reached 500. So this is what is important, how much you publish in high quality journals per annum. But look at Moratuwa, they have a sudden development. They were in the range of 100 to 150 from 2005 to 2015. And for the last few years, they have taken the driving seat and they have increased up to 600. So main reason is when Moratuwa offer conferences, they link their conferences with Scopus or any other publisher. Thereby, they get the contribution of Moratuwa papers in publishing in main big places. So, other universities you can see, Jayawardhanapura, Kelaniya, they publish nearly 250 papers per annum. And Ruhuna as well. So Jaffna at the range of 100. So I heard that the previous speaker said IRCUWU is at 88, which is a very high number. So if you can reach to 300 next year, you will become place within 5. So these are the targets actually. This is the way how actually you can manage your research. So research allowance is there, but research awards must be introduced, and so many methods you need to consider in order to develop individual research. May I go to the next slide, please? Look at this. This is, again, very much important. You can see the rate of growth of papers. So, University of Moratuwa, as I told you in the previous slide, they record 68.5%. This is the way how they have climbed the ladder. And University of Colombo placing number 2, 43.1% increase per annum, and USJ 33.7, and Jaffna 12.3. Next will be another interesting one. Please go to the next one. Look at this. This is what actually I want to show UWL's academics. So you have 4 universities here, 3 in the other. I will show you that also later. You can identify what is your strength. What is your strength? Actually, I did all this data collection at the UGC. Few of my colleagues have helped me from Jayawardenapura. So you can see this interdisciplinary is number 1 wherever you go. So you need to strengthen this area. Look at all universities except Moratuwa, right? Jaffna, Ruhuna, Peradeniya, you can see the green part is the highest. Look at the second best in Jaffna, it's medicine. Then Ruhuna, physics, that is in science. Then Peradeniya, again medicine. So Moratuwa, it's engineering. So like that, you can see social sciences won't contribute much. Social sciences coming in the latter part of publications. So if you have very good science base in the university, numbers in publications. Shall we go to the next slide, please? Thank you. So same scenario, you can see green is interdisciplinary, and then again you can see Kalaniya, Colombo and Jayawardenapura medicine. So good to have a medical faculty at UWA. Professor Ratnasekara is having discussions with 2 ministries, health and education at the moment, to establish UWA medical faculty very soon. Then you can see the first, second, third and fourth, all science-based. Only at Jayawardenapura, you get social sciences at number 5 because of the large management faculty. This is about high quality publications. Shall we go to the next one, please? This one, these are the number of circulars that we have issued so far. For recruitment circulars, 352. Salary related circulars, this, look at research, only 2. So this shows how much we promote research in our system. No directive, no management. In order to establish a proper managing system, I have studied, and that is what I have actually today presented to you. Only this research to numbers dedicated for research allowance. That is also, credit must go to the FUTA, right? Because of the FUTA work, UGC have developed these 2 research circulars. So UGC is having discussions in order to establish research faculties in all universities. They have to manage research. the biggest problem in our system is there is no dedicated authority to manage research. So to fulfill this gap, we are now planning and having discussions, continue discussions to overcome this weakness, and probably we will be able to establish research faculties where you can collect information, promote individuals, and you can bring down foreign collaborations and to promote research. Shall we go to the next slide, please? This is data. It's not available on screen. If you come on www.ugc.ac.lk, you will find all webometrics data. Actually, I have collected for the last 10 years and we are displaying all information. So 5 years ago, IRCUWU was 22nd in Sri Lanka. And you have placed, according to webometrics, somewhere in 13,000. Not a good place. But today, somewhere around 9,000. So there is a huge development in research at IRCUWU. Very admirable when you look at the research development in the sense of publications. And today, you have placed 9 in the country. That is also a development. I believe that this type of research conferences, not at the domestic level, always inviting and bring down foreign speakers, foreign researchers, and at the same time, if you can have a link with top-level publishers in order to send IRCUWU papers for publishers. If you can send 25 from today and tomorrow, then you will be placed in a better position. So these are the things actually I want to highlight. I wanted to physically come to IRCUWU for the conference, but unfortunately, because of this pandemic situation, it was not materialized. Thank you very much inviting me, Vice Chancellor, all deans and conference chairman. Thank you so much, and expect a brilliant performance from IRCUWU in near future. Thank you very much. You are muted, I suppose.
Good morning to you all. It's my great pleasure to introduce Professor Yuan Wei, who is my PhD supervisor. Professor Wei got his bachelor's degree in chemical engineering from Jiangxi Polytechnic University in 1990 and his master's in environmental engineering from Dalian University of Technology in 1995 and PhD in environmental engineering from Research Center for Eco-Environmental Sciences, Chinese Academy of Sciences in 2000. He has served as a postdoctoral at TNO Netherlands and visiting researcher at EWAC in Swiss Federation. And his research areas focus on water and wastewater treatment, organic solid waste treatment, and resource recovery, river restoration, antibiotic resistant pollution, and controlling environment. He has supervised over 50 master students and over 25 PhD students and published over 300 papers in peer-reviewed journals. His H index is 31. And as the PI, he have completed over 30 projects funded by National High Technology Research and Development Program of China, National Major Science and Technology Projects of Water Pollution Control and Management of China, and National Natural Science Foundation of China, and also other several local and provincial level government institutions. With his great contributions, Professor Wei was able to push CAS authorities to establish a dedicated water technology laboratory in Sri Lanka, which was established in University of Peradeniya premises as a donation from Chinese government. He will be acting as the director of that China-Sri Lanka Joint Grant Research Center for Water Technology from Chinese side. Today, he will join with us live from Beijing. It's over to you, sir.
Yeah. Thank you so much. Thanks, Dr. Titus. Introduction. So I will share my screen. So can I share screen? Yeah, okay. So can you see my slide? Hello? Can you see my slide? So
Yes.
okay, so yeah, okay, thanks. So dear distinguished guest, dear Vice Chancellor, dear conference chairman, dear conference coordinator, and dear conference secretary, Dr. Titus. So I'm very happy and honorable to be here and to make a speech. So I would like to focus on the experience of water pollution prevention and control in China during the past 40 years. So as we know, in 2015, the UN released the Sustainable Development Goals. Among these 17 goals, so there are some goals related to the water pollution prevention and control, like the SDG 6. For example, the SDG 6 is their clean water and sanitation. In this SDG 6, there are several contents related to the water and water pollution control prevention. For example, they provide safe and affordable drinking water for all, to access adequate and equitable sanitation and hygiene for all, and improve water quality by reducing pollution, eliminating dumping and minimization these hazardous chemicals and materials, having the proportion of untreated wastewater, and substantial increase in recycling and safe reuse globally, and also expand international cooperation and capacity building support for developing countries in water and sanitation related activities programs, including the water harvesting, desalination, water efficiency, wastewater treatment and recycling, and the reuse technology. So that is this SDG can provide very useful and helpful guidance for our future cooperation. So as we know, in the world, there the water issue is very key issue. They relate to the water quality and the water quantity. So from this slide, we can see, so for the available water, so you can see that in the Asia, the population is roughly 60% of the world, but the available the water is roughly 36. So this is not maybe is not enough for the population compared to the North American. So for the North American, the population is only less than 10%, but the available water source more than 15. So that is, we can see the water resource distribution generally is uneven in space and temporary. So we also can see the water quality. So you can see this is the water quality in the OECD countries. They treated the wastewater and the water pollution loading the global waterways is much less than the non-OECD countries. Why? Because the OECD countries, they treat the wastewater higher than the non-OECD countries. We also can see the global water security. So for the global water security, including the quantity and the quality and also the flooding. So we can see in the past 100 years, so water use increased by 100 times. Each year, the increase rate is roughly 1%. So, during the urbanization and the population increase, so the water use and the water resources, their confliction is very serious. And we also mentioned that climate change will serious to impact the water resource. And sometimes in some areas, there are severe water shortage in some regions. So this is the fix, we can see that. And also, but how to mitigate the water security, how to guarantee this the water security. So we can see the wastewater may be play important role because wastewater is a reliable source than the rainwater. So for example, so because in the developing countries, the most of wastewater is untreated compared to the developed countries. So there will be great potential for the wastewater treatment and the reuse. So this will be plays an important role for to provide the water resource. We also can see this is the water quality. So you can see this is the risk index in the world. So and during in the past, so the population density and the economic development are the major two factors affecting the water quality. So during this is you can see this is the area the water quality is not so good compared to North Americans and the European. So that is a big challenge. This is like the South Asia, and this is the Eastern Asia. There are lots of challenges for the water pollution control. We also can see so the water pollution is exacerbating in Africa, Asia, and Latin, many in the river water quality. So and also we know that lots of people use the river surface water as the drinking water source. So for this, there is now the big challenge for global water qualities are nutrients and the pathogens. Nutrients including the nitrogen and the phosphorus, and the pathogens like the bacteria and the virus. So we can see that some way how to deal with this global water scarcity. So we can see this is the water quality, the status in the what is the quantity. So there are different way in the past, different way to deal with the global water scarcity. There are three ways. One way is based only based on the quantity. Another way is including both water quantity and the quality. And but if we consider the non-conventional water source like the wastewater and the seawater, so we can, if we consider to get desalination and the treated wastewater reuse, we can provide another sustainable way for the global water scarcity. So this is the way. So from this, if we expand the treated wastewater reuse and the desalination, for this will be a good way to deal with the global water scarcity. So that is very important. Why the water pollution control, and it's so important. So that is I just briefly introduce the global situation. So I will come to our China. So we face a similar problem. This is the China watershed. So in China there are many watersheds. There are the 7 major watersheds accounted for 43% of the land area of our country. So this is the Yangtze River watershed. This is yellow one. These are famous the river system in China. They are mother of China. So you can see in the past 40 years, so our population increase is also very quickly. So you can see there now our population last year is 1.41 billion, and the urbanization population is also quickly the urbanization urban population 64%. So you can see the GDP is also increasing very, very quickly, especially in the past 40 years. So now China is the second the economy country in the world, the GDP, but the GDP per capita is still very low, roughly $10,000. So this is the basic information. So we can see how about the water resources in China. So, and you can see generally per capita water resource is roughly 2,000 cubic meter per person. But this is okay. But compare the lots of countries, this is very low. Especially you can see the Beijing city, there is very, very low. The per capita water resource is roughly 115. So, but you know that in our country, so the water supply is very good, and the water use is also very good, especially for the urban area. For example, for the this is the water coverage in the urban area is nearly 100%, and also, but for the wastewater is also increased in the urban area, but the rural area is still very low. So, and in the water use, we can see agricultural water use is the major part of water use, and but now the domestic use is increasing very quickly. But industrial water use is stable, roughly 20%, and also ecology use is increasing because we should protect our environment. So, and we also can see this is the water supply for the urban area. So you can see, and that is one. And so in the past 40 years, the water supply increased very well, and the water consumption is also increased very much. So it means if you use more water, it will produce more wastewater. So, and how to deal with it, so that will be a great challenge for our country. So, and you know, in our water supply, we use water a lot. So how about our China, the environmental protection, the history? So I think there are 5 stages. So our goal is to construct beautiful China in the future in 2035. So in this, there we focus on the 3 parts: management, including the strategy, master plan, law, policy, regulation, guidance, standards, and the technology, process, method, materials, equipment, and infrastructure, facility, and capacity, like the wastewater treatment plant. So before the 1971, there is nothing little about the environment protection, and in 1972 to 1991, this is 20 years. So during this period, the environment protection was set as the basic national policy of our country, but still they are not too much. They are only focus on the initial stage, and then in 1992 to 2000, we made the sustainable development policy. So with we released the China Agenda 21st. This is the UN the minimum goals. Okay, suggesting the pollution control for key watershed and regions. In 2000, in the 2001 to 2012, we made the environment friendly policy, the society, the country. So implementing pollution emission control and demonstrating eco-province and eco-cities. And since 2013, we make the ecological civilization policy. It also put into the constitution of China. So beautiful China there's two parts. Ecological civilization, beautiful China, was adopted by the amendment to the Constitution of China. So in the future, so this is our the fundamental policy for the future. So, and this is the general. So we want to know for the water pollution prevention and control in China. So you can see there are the major 3 stages before 1995. So our the water pollution control mainly focus on the pollutant pollution, especially the mainly for the industrial wastewater. There are the lack of the environment monitor and management. And since 1996 to 2020, in this 3 5-year plan, you know, our country, each 5 year will make a plan. So we focus on the key watersheds, including 3 rivers. These 3 rivers, the water pollution is very serious. 3 lakes, the same. Then come into Sanxia Reservoir and Songhuajiang River and Yellow River. So this one. And since 2011 till now, so we promotion the nationwide water pollution prevention and control. And so spreading the key from the key watershed to the nationwide nationwide. So especially we focus on it's very, very important. In 2015, we made an action plan for water pollution prevention and control. Since then, there are lots of things to make change. So during the 1996 to 2010, so we also set the target for the water pollution reduction. But for this, only one target for use the COD. And since 2011, we use the COD and ammonia, nitrogen, and also water quality. So this target, there are different targets. So, and for this one, so there are also lots of research. So I want to know, so I also will tell you there are some causes for water pollution in China during the past 40 years. You know, in the 40 years, China experienced a very fast development. So such development, rapid development and urbanization resulted in the select water shortage and water pollution. There are 3 levels causes. The fundamental causes are the structural imbalance, like the water resource, water use, and the ecological water use. So because this is the fundamental cause, and the major causes for the water pollution shortage is the rapid industrialization, urbanization, agricultural intensification. So this one, and the important cause for the pollution is like the river corridor fracture, aquatic chemical damage, aquatic species depletion, loss of self-regulation of the and the surface ecosystem. So that is the fundamental. This is we generally make the summarization. So how to deal with the challenges. So we can see we always focus on from the water source, pollution source. We focus on the pollutant point pollution, like the industrial and the domestic source, and the diffuse pollution, like the urban, agriculture, and rural sources. So this is, in the first, we focus on the point pollution, especially on the industrial, then spread to the domestic. And now we also spread the diffuse pollution. So for this, the water source, they discharge some major water pollutants. In the past, in the beginning, we focus on the conventional pollutant, especially COD and ammonia, nitrogen, and the total nitrogen and the total phosphorus. And then it's spread to the toxic pollutants like POPs, heavy metals, PDS. And now we are also spreading to the biological pollutants like pathogen, virus, antibiotic resistant bacteria, and ARGs. So how to do this? So this is because this water source, water pollutants will cause some control. the aquatic ecosystem degradation. So because it means ecosystem service loss and also water scarcity, including the water quality and also quantity. So how to deal with this? So we use the different policy principle. Now we use the ecological civilization. So we make the integrated solution, policy and technology and management, so that we can make clean water. This is our general and the idea. And for this, for example, so we can make summarize in the past. So our water pollution prevention control make great achievement. So there's something like that. So for the management, we focus on the law and the policy, regulation, standards, and guidance. For the technology, we make the research and the development, and also the capacity building infrastructure, like the sewer system, wastewater treatment plants. So all of this is our governance, especially our government plays a key important. Why do that? So we, each 5 years we make master plan and also provide the continuous financial support. So that is, we can improve our water environment and water resource and aquatic services. During all of this work, the research plays very, very important role. So, okay, so, and now I will show you some result. So in the past 10 years, we made 2 pollutant source census of China in 2010 and in 2007 and 2017. So you can see this is a major pollutant. So you can see this, the discharge, this discharge pollutant decreased very well. So you can see this is for the industrial source decreased very well, but the agriculture also decreased, domestic also decreased. So but from this view also you can see the domestic source plays more and more role in the pollutant discharge. So so we can see this is one, and we also there's some key facts. So for example, the concentrated wastewater treatment plants so is very huge, nearly 8,000. But for the municipal, roughly 9,000. So most are from the rural, the wastewater treatment plants. This is small scale. So with this is the infrastructure of wastewater treatment plant. So the reduced pollutant is also very huge. You can see this is COD, ammonia, nitrogen, total phosphorus is very huge. And but during this wastewater treatment, so they also will produce lots of sludge. So sludge production disposal. So this is also a big challenge. So, and I will show you that different way to treat and dispose of the sludge. So, and we can see, and this is current the freshwater environment quality in China. So you can see in China in 2019, the better water, just grade 1 to 3, is roughly 75%. So that is very good. So I will show you next slide. Compare 2005, it's improved very much. So and also the water quality, river basins is also improved very much, especially in the seven major the river watershed. So all in this surface water, the major pollutant, the COD and the total phosphorus. So you can see this is the progress, surface water quality improvement. So you can see this in 2005, the grade 1 to 3 is not so good. So this compare this to 2019. So we can see that is a very great improvement. And now this is the red color means better water quality. So and in 2019 it decreased very much. So we are happy to know this, but this is the general information. But also know in our country, lots of people use drinking water, surface water as a drinking water source. So, and during this, the water improvement, there are also some challenges. The surface water quality. What is nitrate pollution? Nitrate pollution, because nitrate pollution will cause some of the problem. So this is study shows our very big information. Roughly 80% surface water that nitrate concentration over our standard. So most of are very good. So so we also know what is the primary source for the nitrate in the river water, most from the milieu, septic tank, inorganic fertilizer, and the soil organic matter nitrification. So, and this nitrate concentration also has a very positive relationship with the GDP, the nitrogen fertilizer, and the wastewater discharge and the population. So the urbanization, and agriculture, will be the major factors for the nitrate. We can see this is the primary pollutant pollution surface water in China. So this is from 2003 to 2018. We can see this one. So yes, we are the surface gray water footprint is decreased. This is based on this the gray water and the spatial distribution in different regions. You can see most from the eastern side is very serious. So it's including the COD, ammonia, nitrogen, total phosphorus. So this is a very good reference for decision makers and government. And we also can see this. So, and from this one, so this is the figure which shows the primary water pollutants are total nitrogen in this area. So in this area region, only the ammonia nitrogen. So this is the total nitrogen. Most of are not ammonia, are nitrite. So this is nitrite is a big issue. This is the research confirmed the last research. So this is a different province, 31 province in China. So we can see this one. This is very good. So with this the data, we can very clear understand what we can do in the future. So from this, so we can make the summarization. So there are different way, different source for these water pollutants. So we can see this is the primary water pollutant is already changed from the COD to total nitrogen. So most are used is the nitrite. So this is very clear. So for this one, that is very good in the future for our future work, how to deal with this. And this is the major water pollutant across our country. So we also can see the wastewater treatment in China. How is it going? Very well. So you can see the wastewater discharge increase very quickly, and also the sewer system is also increased quickly. And this is the wastewater treatment is also increased very quickly, especially since 2000 years. So this data very clear shows us, for example, and in the urban area, the wastewater treated is roughly 95%, and in Beijing, the 97%. So, and the recycled wastewater, and in our country, not very high, at roughly 22%, but in Beijing, nearly 6%. So this is very, very good. So, and also, you know, and in our sewer system, there are lots of some combined sewers, but this is the percentage is not high, not like the developed countries, roughly 40%. And Beijing is very low, much less low, 9%. So, and now in the urban area, especially in the wet season, the combined sewer overflow is a very important role in the urban water-borne pollution. This is the combined sewer system in China. So we can see, and this is the combined sewer system. Combined sewer system. This ratio is decreased. So and this is in 2016. The combined sewer system, the ratio is low compared with the developed countries like Germany, Japan, and the UK. So you can see this. So this is also let us know. So in the future, this is a very important issue for the urban area. So we can see this. So we just mentioned the urban area, and now we can see that all the countries the sewage treatment. So this is for the rural sewage treatment rate is very low. So now in the future we should be increase it. This is for the urban area. That is no problem. And also this is the wastewater connection. So you can see we increase very quickly. And also you can see this is the in some of the key regions. This is the Jing-Jin-Ji, Beijing, Tianjin, and Hebei province. This is very important. This is when the Yangtze Delta, like the Shanghai, is here. So this is the urbanization and the population density is very high. So if during this area, so we should that's a big challenge for our future work. And also we mentioned in the former slide, so the sludge treatment disposal is a big challenge in the future. We make great progress in wastewater treatment, but the sludge treatment also should be improved. So you can see this is our the different way for the sludge treatment and the disposal. So in 2019, so the sludge production is very high, is roughly 40 million tons, and roughly 30% was disposed by the land application, and followed by the incineration and then landfills. So these are the mainstream technology for the sludge treatment. As we know now, we are country promised to reach the carbon peak in 2030 and the carbon neutral in 2060. So and the sludge treatment disposal will play more important role in the carbon neutral in wastewater treatment plant. So and also you can see for the carbon emission, equivalent emission, the incineration is the big one, the biggest one. Then the sanitary landfill, then land utilization, something like that. So how to balance the carbon emission and carbon neutral in the future is also a big challenge for our future. So and this slide shows our the municipal wastewater treatment plants in the urban area. This is in the urban in 2017. So and in this is the municipal wastewater treatment plants, most of the process is the A2O, which is the anoxic and oxic process. Like this, the ratio is roughly 30%. Others like it is the CAS. It is a CAS. It is a CAS. CAS is a process. So but for the NBR, the NBR process is not too much because the NBR compared to the conventional activated sludge process, NBR may be a high cost for investment and maintenance, but for the high standard and wastewater use, NBR application is becoming popular. This is the wastewater treatment plant for industrial wastewater. So because you know the eastern area of China, the population is high population, high GDP. So this is the same. There's also the high industrial wastewater treatment in this eastern area. So that is very clear. So and also, so all of this, so we can make it because different city there is in charge of the water pollution prevention and control. We can compare. So how about the total factor performance of wastewater treatment in different cities. So because wastewater treatment plays important role in mitigating water shortages and protecting water bodies, but the bad wastewater treatment will become the main barrier for the regional water pollution control and sustainable development. So according to this, we can classify four types cities. The type 1 is high technical efficiency and total factor performance of wastewater treatment plant. There are only roughly 8 Beijing and Shanghai, some cities. Most of are type 2, are type 2 and type 3, and even the type 5, 4. So all of this should be improved in the future for this city. So this is the research result is very clear for the government and the decision makers for our future work. So, and now I will briefly introduce the NBR, because NBR process is very useful and effective for the wastewater treatment and wastewater reuse. And in China, the NBR technology grows is very quickly in the past. This is the driving force. I will brief the NBR the technology in the world. So since 2000, that is increased very quickly, and especially China. So China becomes the first NBR application in the world. So this NBR development in China. So now it's the biggest one, NBR wastewater treatment plant. Now it's located in Beijing. The capacity is 200,000 cubic meters per day. So that will be, we would like to share such experience with Sri Lanka and Sri Lanka students. So for example, in Colombo, in some big cities, there are some wastewater treatment. If possible, we can use this technology for this claim. And also global market, NBR is increasing very quickly. So you can see very quickly. And also, and so we want to understand NBR plants. How about the performance? You can see this is a survey as 19 large-scale NBR in China. Of this is the flux, so is good, the north and the south. So the flux is between the 15 and the 20 liter per square meter per hour. So that is very fine. And also the pollutant removal is very excellent. The COD, ammonia nitrogen, total nitrogen, total phosphorus is very high. All this is very high. So that is, it can provide high quality effluent, also can for the wastewater reuse. And this is for the wastewater compare the conventional active sludge process. So NBR can have better virus removal. You know, at this moment, COVID-19 pandemic, this is microbial pollution and control plays more and more important role. If we use the NBR, it will provide more sort of support for this. So we also can see for this NBR plant is also can have a very good, excellent for the industrial wastewater treatment, and different that is very good. And this, for example, food, beverage, textile, petroleum liquid also can have very good performance for the pollutant remove. And also for compare this, there the operation and the maintenance cost for the industrial wastewater is also good. And but in this, the labor cost, this is from the developed countries. Maybe for developing country, maybe the labor cost is not the big issue. So, and this is for the different the wastewater. So you can see this is for the industrial wastewater labor, but this is the result from the developed countries. If developing country, that is different. Maybe the energy for developing countries, energy and chemicals. Okay. So, and this is, I will show you all this NBR plans distribution in China. So now China becomes the #1 NBR application in the world. So because to mitigate the water shortage and save the water pollution control. So this is the NBR application in China. So it's ideal. So increase very quickly. So that is, and this is in China, in Beijing, the locations, NBR, something like that. So during the speech, I just brief make a summarization and the retrospective of China history and experience in the past 40 years. So in the future, I think our country, the goal is to construct a beautiful China. So that's some key challenges. For example, integrated watershed management and protection key water bodies like the Yangtze River and the Yellow River. So, and our country launched this is a big program for the Yangtze River and the Yellow River protection and the diffuse pollution control, especially for the rural area, agriculture diffuse, and also integrated management system for the aquatic ecosystem health. Ecosystem, like the river, just like a human being. So if we want to the river, the health, so we should do that. In the first, improve the water quality, then restore the river system, then improve the health. So in the future, that is our focus. For example, and our country also makes the 14th five-year plan and outline the goals of 2035 in China. So we can follow this, the master plan to do that. And also last year, our country also make promise the carbon peak in 2030 and carbon neutral in 2060. So based on this, the framework, we will do that, our future work. So improving water environment quality, aquatic ecosystem health, and scientific protection, the river, lake, urban water body, and drinking water source differently, and the comprehensive control pollutant discharge, and continuous improving water ecological environment quality, improvement the water ecological environment management and the security system. So that is our future work. Thank you so much. I'm very happy to share our experience. And I just make a brief summarization. I hope this speech can provide some reference for you all. Thanks. Thank you so much. Yeah.
Thank you so much, sir. It's a great honor to have you with us today. Now, I cordially invite Dr. Asanga Samaravira to introduce Professor Ramesh Jimani, keynote speaker of IRCUWU2021 together.
Thank you. Good morning, everyone. It is my great pleasure to introduce Professor Ramesh Mani. He is again my PhD advisor. Professor Mani completed his undergraduate and graduate education at the University of Maryland, College Park. He worked as a guest scientist at the Max Planck Institute in Stuttgart, Germany, where he invented and developed the anti-hole bar within the hole bar configuration, which helped to demonstrate sign reversal of the Hall effect within voids and the possibility of dual simultaneous ordinary integral quantum and fractional quantum Hall effect in a single multiple connected specimen. From Stuttgart, he returned to the USA with a position at the University of California, Santa Barbara before moving to Harvard University. While at Harvard, he discovered the radiation-induced zero-resistance states and also quarter-cycle shifted magneto-resistant oscillation in the gallium arsenide, aluminum gallium arsenide two-dimensional electron systems. He subsequently moved to Georgia State University, where he has established a nanoscience, low temperature, and high magnetic field laboratory in order to examine low-dimensional electronic systems based also on modern materials such as graphene. He has supervised several PhD and master students, published over 170 papers in peer-reviewed journals with several authorized patents. Currently, Professor Mani serves as a full professor at Georgia State University, Atlanta, USA. Professor Mani is joining this occasion virtually from Atlanta, USA. Now its local time is 1 a.m. So we really appreciate Professor Mani for your participation in this event. Now it is time to listen to his talk by Professor Ramesh Mani. Thank you very much.
Hello, everyone. My name is Ramesh Mani. I'm at Georgia State University in Atlanta, Georgia. And it's a great pleasure to be here today at the 5th International Research Conference of IRCUWU2021 University. And it's good to be hearing about exploring potentials in a challenging period. So today I'll be talking about graphene, a new material. And here's the condensed outline for the talk. So there'll be a broader introduction to start with, and then I'll tell you a little bit about some experiments on spin resonance in graphene. So we live in a world full of electronics. We're surrounded by cell phones, video cameras, GPS systems, tablets, cameras, and so forth. And all these things are possible because of modern electronics. But it turns out that there's a lot more electronics in our lives than we realize. For example, light bulbs may also be viewed as electronics these days because a lot of the bulbs are LED bulbs. And then, of course, solar cells are solid-state devices which convert sunlight into energy, and they're a green solution. They don't provide energy without creating pollution. It turns out that there are also a lot of electronics in modern automobiles, and the modern automobile is filled with sensors. For example, there's the transmission sensor, the wheel speed sensor, the throttle position sensor. All of these things have electronic devices included in them. So the standard for material for electronics has been silicon for a long time. And so here we have a picture of a silicon bowl. So this is a huge piece of single crystal silicon. It's 12 inches is like this, 18 inches is like this. And the size of this bowl has been getting bigger with time. So the idea is that they take this bowl and then they cut it into slices, and then they polish the slices, and then all these slices, they make chips, and then they break them up and then put them in packages, which appear in our devices. So back in '69, the standard size for a wafer was 2 inches. And then by 1992, it became about 8 inches. And then currently we're up to 18 inches. Right? So it's a huge size. So silicon has a lot of advantages, which is one of them is a very low cost advanced processing technology. It's a material that's easy to handle. It's a hard material, but the material does have disadvantages. It's inflexible, the band gap isn't direct, and the performance degrades at higher temperatures. So in addition to silicon, there are a bunch of other semiconductors which help to complement its capability, do things that silicon can't do. For example, gallium arsenide is good for microwave integrated circuits, infrared LEDs, solar cells, laser diodes, and so forth. Gallium arsenide has a band gap of 1.42 electron volts. Then there's indium phosphide, with a band gap of 1.35 electron volts. And this material is good because it can be used to produce lasers, detectors, and modulators at a wavelength of 1550 nanometers. This is an important wavelength because these days we use optical fibers for communications, and optical fibers are most efficient at this wavelength. And so indium phosphide complements optical fibers. And then there's also gallium phosphide with a band gap of 2.26 electron volts. This material is interesting because it can be used to build up green LEDs. As you may know, the human eye is most sensitive to green light. And so green is an important part of the spectrum, and gallium phosphide helps to build devices in that range. And then there's also gallium nitride. This is turning out to be an important material because the band gap is very large here, 3.39 volts. So that means you can make optical devices with a shorter wavelength. For example, if you want to do blue LEDs, then gallium nitride is good for that. Gallium nitride is also being used to make white LEDs for lighting applications. It's also an important material for high power electronics. So for example, in a car where you are using big motors and a lot of current to drive these motors, you need high power devices. And so gallium nitride could be in such automobiles as DC-AC inverters and DC-DC converters. So silicon, along with these other materials, have sort of helped create the world of electronics that we know today. Now, it turns out that there are many other desired properties that we'd like to have in electronic materials that we don't have so far, and at least the degree that we'd like to have it. And these include things like transparency, high electrical and thermal conductivity, flexibility, less weight, using less power, tunable band gap, so you can select the color of light emission. And then you also want ultra high frequency operation in hundreds of gigahertz. And it turns, plus other new materials that are not available in natural materials. So, we have materials that do a lot of things for us, but there are a lot of other things that we'd like to do, that we would like to have. And the reason we'd like to have these things is because, people are imagining a future with electronic devices that, we can just imagine these days. Things like, wearable electronics, clothes full of devices, extremely high efficiency solar cells. And, there are also new applications like virtual reality, self-driving cars and self-piloting airplanes, robots, artificial intelligence, and so forth. So this brings us to graphene, which is the modern wonder material. Turns out graphene has a lot of these properties that people have been seeking. For example, it's super strong, amazingly thin, almost completely transparent, very light, and an excellent conductor of heat and electricity. Turns out that graphene is better at carrying heat than any other material, right? Better than silver or copper, graphite or diamond. And I especially like this one property for graphene. You can cover a football field with a sheet of graphene weighing less than a gram, right? So, which is an impressive capability. And then it turns out that electrons are more mobile in graphene. And so this means that, the electronic devices using graphene could work faster. They could use less power than, the materials we're using today. And also graphene provides new properties, which are properties expected in systems exhibiting relativistic quantum mechanical characteristics. So, you could get some new properties in this material. So it turns out that back in 2010, Andrei Geim and Konstantin Novoselov got the Nobel Prize in Physics for groundbreaking experiments regarding the two-dimensional material graphene. So what is graphene? Well, in a sense, you already are familiar with it. You know, graphite. Here's a chunk of graphite. It turns out that graphene is just the layers of carbon that make up graphite. So if you want graphene, what you have to do is you just peel off one of these layers and then isolate it, and you've got graphene. And it turns out that, for this conference, it's also a very important material because graphite has been linked with Sri Lanka for a very long time. So here, for example, we have some rocks, and this rock, you see this blue vein, and this is a vein of Ceylon graphite. So, Ceylon is the former name of Sri Lanka. And, hundreds of years ago, when they first discovered this graphite, they called it Ceylon graphite. And it turns out that this graphite is some of the purest graphite you can find in this world. It's 95 to 99% pure carbon. But it only accounts for less than 1% of the world graphite production. This graphite in Sri Lanka was known even back in 1675 when the Dutch governor recorded its existence. So it turns out that in the present, Sri Lanka produces about 4,000 metric tons per year. And the price for this is around $2,300 per ton. Of course, the price depends on the quality. So this graphite that's mined in Sri Lanka has been used for a long time, things like electrodes for dry cell batteries, right? And now it's also being used in lithium-ion batteries, right? And because graphene is becoming important, this kind of graphite, which is very pure, it could also play a very important role in the development of graphene. So there's another reason why graphite is going to be even more important in the future. And that's because, in the near future, all cars are supposed to be fully electric, right? So here are some electric cars being offered on sale in the US. So, you have the Tesla, the Porsche Taycan, the Nissan Leaf, Chevy Bolt. All these are fully electric cars. And these cars, they use these lithium-ion batteries, right? And so even if lithium-ion batteries don't change, right? Even if they don't get better than what they are right now, there's still going to be a lot of growth for graphite because people are going to be buying more of these electric cars which have these lithium-ion batteries in it. And people say that it takes 20 to 30 times more graphite than lithium to make a lithium-ion battery. So a fully electric automobile uses 110 pounds. So, if you scale up the automobile market, and the electric market is very small right now, it gets to be huge, you're talking about a lot of pounds of graphite, right? Now, the reason electric cars are not that popular right now is because, they're popular, but some people are hesitant to buy them. And the reason for that is because, they don't hold much energy, and it takes a long time to recharge them, right? And these problems occur because of the way these batteries are made. So, here's a lithium-ion battery, and this is the cathode. The cathode includes transition metal oxides, and the anode is mostly graphite, and it's a special form of graphite. It's spherical graphite. And so, if you take Ceylon graphite, which is 95% pure, you have to first purify it, and then to 99.95%, and then you have to make it into spherical graphite before it goes into this lithium-ion battery, right? And then even after you do that, your recharge times are long, and energy density is not that great. And part of the reason is because this graphite, when you try to recharge at a high rate, you get a lot of heating at the cathode and anode, and also you're not able to store as much lithium ions as you would like to here. So the way these batteries work is when you're charging the battery, lithium goes from the cathode to the anode. And then when you're ready to discharge the battery, the lithium ions go in the opposite direction. And then there's an electron current in the external circuit to balance it, right? So, energy density depends on, stored energy density depends on how much lithium ions you can store here, and then how quickly you can get them in and take them out. So people say that if you use graphene in some form in these anodes, you can get up to 10 times faster recharge rate, right? By improving electron and ion transport around the anode. And so, if you can charge the battery 10 times faster, you will have a lot more people willing to buy these electric cars. And if you can store even more energy in these batteries, then you increase the range. Anyway, so on to other forms of carbon, right? So we said that graphite can give us graphene, which is just sheets of graphite. It turns out that there are other forms in which we can find these graphene sheets. If you take a graphene sheet, cut out a piece, and you roll it into a tube, that's called a nanotube. And then this was discovered in 1991 by Ichima. And then if you cut out a piece like this from your graphene sheet and you roll it into a ball, that's called a fullerene. This was discovered in 1985. And then the Nobel Prize for it was awarded in 1996. So it looks like finding these different forms of carbon were sufficiently interesting to be awarded the Nobel Prize, right? So carbon research is good. Now, the thing is, graphene has given us a new concept, and this is this concept of 2D atomic layer materials. So it turns out that in addition to graphite, there are other materials, like, for example, hexagonal boron nitride, molybdenum disulfide, tungsten diselenide, fluorographene, a whole bunch of other materials. All of these things are sheets loosely bonded together, and all these materials can be peeled apart an atomic layer at a time. And people have done this. And so the idea is, suppose you isolate atomic sheets of these different material, and then you stack them as you would like to stack them, based on theoretical expectations, for example. And then the thinking is that this would lead to materials with properties that can't be realized in nature, perhaps, right? You can engineer new materials that you'd like. And then these materials that you build up by stacking these atomic layers, they're going to be flexible because they're very thin. If you have 5 layers of different materials, it's still a thin resulting material, and it'd be easy to flex it, right? And then by inserting graphene in it, you could get high conductivity, low energy dissipation. And then because the materials are thin, they would also be transparent, right? So, a body of physics research is aimed at developing, realizing, and studying these layered atomic materials, right, with potential applications in mind. So now let me tell you a little bit about our physics research. This is kind of a very specialized thing, and I'm not sure that everybody here is going to be interested in it. So I'll keep it brief, right? So as we know, electrons are fundamental particles, and these particles have spin, right? It's a spin half particle, spin can point up or down. And then it turns out if you put it in a magnetic field, then the two spin species develop different energies, and there's a gap between these electronic levels. And this gap increases linearly with the magnetic field. And further, this gap is in the energy range corresponding to, say, microwaves, right? So then the idea is that you take some of these electrons in graphene or some material like this, put it in a magnetic field, create these levels, and then you apply radiation, microwave radiation, and then you induce a transition from, say, a lower level to upper level, and vice versa, right? And then so this would be called a spin resonance, because you're essentially flipping spin with your electromagnetic waves. Now, in electron spin resonance, this is a thing that's been done for a long time in bulk materials. Using various techniques, you can detect this resonance as a function of the microwave frequency and the magnetic field. Okay, so this is a topic with a long history. But the problem with graphene is that the samples are very small, you have very few electrons, so traditional techniques don't work so well to see spin resonance. And so what I'd like to tell you about is our first detection of whole spin resonance using this electrical detection technique in epitaxial graphene. So this was published in this journal here. So it turns out there are different forms of graphene. So this graphene by Novoselov and Gein, right? So this graphene is realized if you take graphite and then you put a piece of Scotch tape on it, you peel off the tape, and then there will be some graphene on your tape, right? So this is exfoliated graphene. And if you isolate that graphene and put contacts and so forth, you can do the things that Novoselov and Gein did. And here, this, exfoliated pieces tend to be small, and the samples are also small on the micrometer length scale. There's also CVD graphene, which is different. Here, what you do is you take copper foil, put it in an oven, and then at a high temperature, you flow methane, which is CH4, and then that has carbon and hydrogen in it. And then the idea is that the carbon decomposes and then forms a layer on your copper, right? And then what you can do is you can remove the copper and isolate the graphene. And then you can put the graphene on silicon dioxide, silicon, or on glass. So here you see this is the graphene, it's transparent. You get huge pieces like this. It's lower quality graphene than exfoliated graphene, but the sizes are much bigger. This is like 1 centimeter, that's like a few microns. And then graphene could also be realized by chemically reducing graphite oxide. This was discussed in the 60s. And then the fourth method, which we used, as epitaxial graphene on silicon carbide. So the idea is silicon carbide has silicon and carbon in it in this crystalline arrangement. You take silicon carbide, you put it in an oven, you heat it to a very high temperature, and then what happens is that the silicon comes off, and the graphene stays back and then rearranges into a graphene film on the surface. So you get graphene on silicon carbide, and this is called epitaxial graphene. So here's a picture of our epitaxial graphene on silicon carbide. Actually, what you're seeing is just the surface of silicon carbide, but it's covered with graphene, right? But you can't see it. And so this is realized by heating the silicon carbide to 1500 Celsius. And then I'll be talking about results in two kinds of samples, 3-layer samples and one-layer samples. So these are p-type samples with holes in the range of 10 to the 13 per square centimeter. This should be 2. Mobility is like 1,000 centimeters squared per volt second. Fermi energy is like 300 volts in the valence band, right? So what do we do with this? We take this epitaxial graphene, we make a device with electrical contacts. Device looks like this. It's a Hall bar with these gold areas are electrical contacts. And then what we do is we pass a current through the device, and then we measure the voltage across some contacts in a 4-terminal configuration. And then the resistance that we report is the voltage divided by the current. So we have a sample like this. It sits at the bottom of a cryostat, and we have wires coming out from the sample. And then there's also a waveguide here. And then we connect a microwave oscillator, excite microwaves, and the microwaves go down and impinge on the sample that's sitting at the bottom. Now, there's also a magnet over here, which is not shown, a solenoid, which produces also a magnetic field in this direction, right? And so we measure resistance versus magnetic field. We do this at low temperatures below 4 Kelvin, which is 4 degrees above absolute zero. And we change the microwave frequency between, say, 10 and 50 gigahertz. So let's see what the results look like. So this is with the sample in the dark. That means no microwaves, right? So if you look at 1.5K, you get this blue curve going out to 2 Tesla. And then if you heat up the sample, curve looks similar, it just moves up. So resistance increases with increasing temperature. This feature over here disappears, okay? So this is the 3-layer sample in the dark. So increasing temperature here means increasing the resistance. So what happens if you apply microwaves? So again, we have resistance versus magnetic field to 2 Tesla. Blue curve is the result in the dark. Red curve is with microwaves, 4 milliwatts at 48 gigahertz. And then what you see is that when you apply the microwaves at a fixed temperature, the resistance goes up. So this is similar to the heating effect, right? So when you heat in the sample, resistance goes up. When you apply microwaves, resistance goes down. But then what happens is that at some places in the magnetic field, the resistance drops back down. It's like local cooling, right? And so there are 2 places where it happens here and over there too. So apply microwaves, resistance goes up. And then what we call resonance is where the resistance comes back down. So there are 2 resonances, one at positive magnetic fields and one at negative magnetic fields. So what we can do now is we can subtract the blue curve from the red curve, right? Subtract blue from red, and then we get brown. And notice this brown curve highlights our resonances. There's one at minus 1.4 and 1.75 Tesla, same at plus 1.4, 1.75 Tesla, right? This is the 3-layer sample. So that was at 48 gigahertz. We can change the frequency from 48 to 42 to 28, 22, and 17. And what happens is that as you change the microwave frequency, the resonance moves to lower magnetic fields, both of them, right? Both the positive and negative magnetic field. Okay, so both 1 and 3-layer samples show 2 resonances. The resonance magnetic fields shift with the microwave frequencies. The first sample showed valleys at resonance, and then 2 other samples showed peak at resonance. But this could be understood. Whether you see valley or peak depends on how the resistance changes with temperature, right? If the resistance increases as you increase the temperature, then you get a valley at resonance. If the resistance decreases when you increase the temperature, then you get peaks at resonance. Okay, so now let's summarize our results. So what we were doing is we fixed the frequency in our experiments, and then we swept the magnetic field. So let's say we're at 42 gigahertz, sweep the magnetic field, and then you get a resonance, and then you get a resonance, right? So that's from one of those traces. Now you can do all these signals that you saw for all the traces, and those are marked here. So sample A is in blue, sample B and C are green and red, right? And remarkably, all these points, they fall on two lines, right? There's this orange line which heads to 0 Tesla at 0 frequency, and there's this purple line which heads to 10 gigahertz at 0 magnetic field, right? The slope, so we can fit a straight line to both of these, and the slope here gives us an indication of the G factor for holes in the system. Turns out if you have a slope of 28 gigahertz per Tesla, that's roughly G factor of 2. Okay, so this is 26.9, so it's almost 2, right? And so from the slope, we can extract a G factor for holes. We're getting a 1.92 and 1.94 for the two curves, right? And then from the width of the resonance, so remember we had a resonance, it had some characteristic width. We can extract, the width was about 50 millitesla. We're going to get a spin lifetime, which is like 60 picoseconds, right? So graphene, one of the things about graphene is that in principle it could have a very long spin lifetime, but in our experiment we didn't quite see it. Okay, so another remarkable thing is that normally in spin resonance you just get one branch, but we're seeing two branches, and further one of these branches has a finite intercept. Question is, how do you understand that? Turns out that so these are the lambda levels for graphene in the magnetic field. So in electronic systems, if you apply magnetic field, you get these highly degenerate levels called lambda levels. Usually those levels are linear in the magnetic field, but for linearly dispersed material like graphene, it goes like square root of the magnetic field instead of linear in the magnetic field. All right, and it also depends on the lambda level index as square root of the index. So these are lambda levels for graphene. Now the thing is, each of these levels is 4-fold degenerate. That means there are actually 4 lines on top of each other. 2 for spin degeneracy and then 2 for sublattice degeneracy. And then let's put that in, but now we're going to magnify the splitting by a factor of 80 so we can see it. Otherwise, splittings are going to be tiny and it won't show up on our pictures here, right? So each of those levels were 4-fold degenerate. We said we're going to lift the degeneracies. Then we get 4 distinct levels. And each of these colors corresponds to 1 lambda level. All of them have 4 lines, right? But the energy scale associated with this lifting is very small, right, compared to our Fermi energy. So we can just gain understanding by looking at one of these, any of these lambda levels. So let's just look at one of these, the 0th one, and then try to identify what we're seeing. So we saw 2 kinds of resonances, right? We saw the resonance associated with the orange line, and we're going to say that's going to be related to our usual kind of spin resonance. But now it can be spin resonance between these brown lines, or it can be spin resonance between the green lines, right? So that's flipping the spin due to photoexcitation by microwaves. And this kind of spin resonance has this usual property, which is that the splitting goes to 0 as you go to 0 magnetic field. Now, if you have sublattice degeneracy being lifted, then you have 2 sets, right? You have the green set and you have the brown set associated with different sublattices. And this splitting over here could be a constant value. And then you could get a new kind of resonance, which is going from a spin for one sublattice to spin of the other sublattice, right? So you could get this new kind of transition, the purple one. And then the thing about this purple transition is that as you go to zero magnetic field, there's still a gap. And so the splitting doesn't go to zero, right? So, let's summarize what we're saying here. So what we're saying is that this orange line over here corresponds to these kind of transitions, the usual spin resonance kind of transitions, but there's one with each sublattice. And then the purple line over here, which has some finite splitting at zero magnetic field, that corresponds to this kind of a transition. And then this kind of transition, even at zero field, you have finite splitting. So from this intercept here, we can get the splitting energy, 40 micro electron volts. And so that's what we say is a sublattice splitting. Okay, so let me summarize our results. So we observed 2 microwave-induced resonance in the resistance and epitaxial graphene samples. These resonance positions shift linearly with the microwave frequency, right? And then we saw the same effect in different samples, which tells us it's some kind of an intrinsic effect. And then we said it was a whole spin resonance. We evaluated the G factor for holes, 1.93. We also, from the width of the lines, extracted a spin lifetime. And we said that maybe we have a zero field splitting of the value degeneracy in graphene.
Thank you very much, Professor Mani. Everything is theoretically impossible until it is done. We have great minds who have made impossibles possible. So it's the time to announce the Research Awards list for the year 2019. As a kind reminder, I would like to remind you that the Research Awards ceremony will be conducted as a separate session in future. UW Research Awards 2019. Category 1. Full article, refereed, non-indexed journal. Awardees are Professor A.M.W.K. Seniratna, Professor E.D.N.S. Aberatna, Professor H.M.J.C. Pitawala, Professor J.P.R.C. Ranasinghe, Professor K.W.S.M. Kumari, Professor P.H.T. Kumara, Professor P.I.N. Fernando, Professor W.A.J.P. Vijayasinghe, Professor M.M.S.N. Prematilaka, Dr. T.H.N.G. Amravira, Dr. T. Prathipan, Mr. H.G.I.M. Vijayasinghe, Mr. H.M.T.N.B. Herath, Mr. J.K.H. Sampath, Ms. K.G.B.A. Samarasinghe, Mr. M.F. Hibatul Karim, Ms. M.S. Kurukulasurya, Mr. N.P.R. Deshapriya. Category 2, full article, refereed, index, journal. Awardees are Professor H.M.J.C. Pitawala, Professor J.P.R.C. Ranasinghe, Professor P.B. Ratnavira, Professor K.W.S.M. Kumari, Dr. A.M.N.L. Abesinghe, Dr. A.S. Ratnayaka, Dr. B.V.A.S.M. Babaranda, Dr. D.P.N.D. Silva, Dr. D.T. Udagadara, Dr. I.D. Sinhalage, Dr. J.T. Kure, Dr. K.G.C. Senaratna, Dr. K.M.M.C.B. Kulatugga, Dr. M.A.S.R. Seneviratna, Dr. R.M. Shashika Dilini Ratnayaka, Ms. H.A.S.L. Jayasinghe, Mr. H.M.T.N.B. Herath, Mr. N.P.R. Deshapriya, Mrs. W.M. Niluni Kusala Vichesundara.
Let me announce category 3, highest citations in the year 2019 from each department. Professor B.K.D.D. Jayasena from Department of Animal Science, Professor W.A.J.P. Vijayasinghe, Department of Export Agriculture, Professor H.M.J.C. Pitavala from Department of Science and Technology, Dr. A.S. Ratnayaka, Department of Applied Earth Sciences, Professor J.P.R.C. Ranasinghe, Department of Tourism Studies, Mr. N.P.R. Deshapriya, Department of Management Studies, Dr. Y.N.S. Vijayawardena, Department of Engineering Technology, and Dr. K.G.C. Senaratna from Department of Biosystems Technology. Next, category 4, Vice Chancellor's Award for the Most Outstanding Young Researcher goes to Dr. A.S. Ratnayaka. And finally, category 4, Vice Chancellor's Award for the Most Outstanding Senior Researcher goes to Professor H.M.J.C. Pitavala. Congratulations, all the awardees. Now we have come to the end of the opening ceremony. So the immense support given by everyone to make this event a success should be appreciated. So I would like to call upon Dr. Titus Kure, Secretary, IRCUWU2021, to deliver the vote of thanks.
The Vice Chancellor, respected invited speakers, distinguished invitees, members of the academic, administrative and non-academic staff, presenters, ladies and gentlemen, good morning. It's a great honor for me to deliver the vote of thanks as the Secretary of IRCUWU at this prestigious forum, the 5th International Research Symposium Conference of IRCUWU2021 University, runs under the theme of Exploring Potential in Challenging Periods. We are extremely grateful to our chief guest, Professor Sampath Amaratunga, the Chairman, University Grants Commission of Sri Lanka, for joining with us amidst his very busy schedule to grace this occasion. Sir, your presence and the thoughtful insights shared with us are a great encouragement for all of us. I must mention our deep sense of appreciation for Professor Yuan-Som Wei, Chinese Academy of Sciences, Beijing, China, and Professor Ramesh G. Mani, Georgia State University, Atlanta, USA, for their valuable keynote speeches on current research trends. Thank you indeed for accepting our invitation and presenting a very interesting research presentation for us, sacrificing your commitments at home. I also convey my heartfelt thanks to Vice Chancellor of IRCUWU2021 University, Professor Jayanthala Ratnasekara. Sir, without unstinted support, guidance, and encouragement, this event would have been impossible. Your advices and timely measures always put us on the right track. Thank you for being the power behind us. Then I would like to thank Professor H.M.J.C. Pitavala for the guidance, support extended as the Dean of Faculty of Applied Sciences and the Chairman of the Research Committee and as the team leader of the conference organizing team. I am also grateful to the all chairpersons and panel members who have sacrificed their valuable time to conduct productive, thought-provoking technical sessions. Moreover, I like to thank all the authors and presenters who have agreed to participate in this online conference. It is my duty to recall the generous services of our reviewers and editors who devoted their time to select quality pieces of work and improve them. Thank you very much. Financial assistance provided by our generous sponsors are also recalled with gratitude. Continuing a great long-term partnership with our university, Bank of Ceylon generously agreed to sponsor our UW Research Award this time. We gratefully acknowledge sponsors' contributions who helped us in numerous ways. Thank you very much. Moreover, my thanks goes to all track coordinators and event coordinators and their teams, and also special thanks goes to conference office assisting staff. Without your support, this event would not be possible. Finally, I would like to record my appreciation for our staff, academic, administrative, and non-academic, especially Mr. Tissara and his technical support team, and also Mr. Bovala and his audiovisual team, and all media personnel who are present here to ensure this event become a memorable milestone in our university history. I take this opportunity to thank all individuals whom I did not mention by name, but contributed in various ways to make this event a success. Last but not least, thank you all for being present here to make this event a success, and I wish you all a fruitful day. Thank you.
Thank you, sir. With that, we conclude the inaugural session of the 5th International Research Conference of UWU. Technical sessions will start from 1 p.m. onwards. We invite you all to join throughout these 2 days. Thank you. And please collect your refreshments at the front door. Technical sessions will start from 1 p.m. onwards. We invite you all to join throughout these 2 days. Thank you. And please collect your refreshments at the front door.